ఓకే. ఎస్. లైవ్ స్టార్ట్ అయింది చూడండి సార్. లైవ్ స్టార్ట్ అయిందిరా. వస్తుంది ఒక్క నిమిషం చూడు. లైవ్ స్టార్టెడ్.
సార్ మ్యూట్లో ఉన్నట్టుంది సార్, వినపడలేదు.
Dilip Kumar sir, good afternoon.
Yeah, great afternoon, Professor. Very great afternoon.
Thank you very much for accepting our invitation and delivering your talk.
In fact, we feel the same. It is our pleasure to be part of your FPP.
Thank you. Thank you.
మ్యూట్ పెట్టి.
Good afternoon to all the participants from various institutions across the country. I am S. Gautam. I'll be representing Civil Engineering Department in Geetanjali College of Engineering and Technology. So on behalf of our department and institution, we welcome you for this 1 week online FTP on recent advances in civil engineering and sustainable infrastructure. So today with us we have the head of the department, Dr. R. Prasanna Kumar sir, and today's presenter, Venkat Dilip Kumar sir, and Dr. Professor S. Tirupati Rao sir.
గౌతమ్.
Before starting the sessions, I would like to read out a few instructions for carrying out the proceedings smoothly. So all the participants are requested to mute your audio and video and also pin the presenter, Dr. Venkat Dilip Kumar sir. Since the limit of this Google Meet is 250 members, so once the members have reached 250, you will be facing some difficulty in joining this meet. So for such participants, we have arranged YouTube live streaming. So the participants can also participate through YouTube live streaming, whose the link was already shared in the WhatsApp groups. So any questions can be asked through the chat box at the end of the session, and the YouTube participants can ask their questions, can send their questions to the group admins in the WhatsApp group. Okay, a feedback form will be shared at the end of each session. I would like to remind, a e-certificate will be issued to all the participants who fill the feedback form at the end of every session, and also at the end of the 1 week faculty development program. Before going ahead, I would like to say a few words about the institution. So Geetanjali College of Engineering and Technology was established in 2005. Over the years since it was established, there has been a dynamic progress in all academic and research activities, and a parallel improvement in facilities and infrastructure to keep it on par with the best institutions in India. It is accredited by NAAC with A grade. Geetanjali College believes in the motto, striving towards perfection. Coming to the department, the Civil Engineering Department was started in the year 2014 with a BTech intake of 120 students. The department is presently headed by Dr. R. Prasanna Kumar sir, who has more than 25 years of teaching experience and 10 years of research experience. The department is well equipped and geared with all the qualified, experienced and committed faculty for teaching, research and consultancy works. So once again, I welcome Dr. Venkat Dilip Kumar sir, the today's presenter, who is Associate Professor in Mahendra Ecole Central College of Engineering.
పెట్టినా అంటే ఎవరు
So regarding the presenter, he's been working as an associate professor in School of Engineering Science, Mahindra Ecole, Hyderabad. He has finished his PhD in Civil Engineering Department from IIIT Hyderabad. He has received a Best Research Award by CAFET Innova Technical Society, Hyderabad. He has also delivered more than 100 expert lectures in various premier institutes across the world. So with these few words, we would once again like to welcome today's presenter, Dr. Venkat Dilip Kumar sir. And I would like to invite head of the department, Dr. R. Prasanna Kumar sir, to address the meeting.
Very good afternoon to all of you, especially the participants who have registered enthusiastically from various parts of India. My name is Dr. R. Prasanna Kumar. I've been working with this department for the last 2 years here. As Mr. Gautam told, the department is the youngest department in the college, started in 2014, and we are shortly going to be accredited by National Board of Accreditation. So we have good quality professors. 4 doctorates are working with the department, and so many people, about 6 people, are pursuing their PhD, and the department is well equipped with all the laboratories and all. Now I am also thankful to the management, the chairman, Sri G.R. Ravindra Reddy Garu, for giving permission, and the principal, Dr. Uday Kumar Susarla Garu, for permitting us to conduct this faculty development program through online mode. I request all the participants to make use of the best speakers. We are fortunate to have very good speakers from across various good institutions in India, like Mahindra Ecole, which has got a university status recently, and we have resource persons from BITS Pilani Hyderabad campus, and we have resource persons from SRM University, Shastra University, who are well versed with both academic and research, plus some industry people are also coming during this week deliberations. I request all the participants to take benefit of these discussions and deliberations, and at the end get maximum benefit out of this faculty development program. With these few words, I welcome you all once again to this faculty development program on recent advances in civil engineering for sustainable day. Thank you.
Thank you, sir. So I now welcome Dr. Venkat Dilip Kumar sir to present the session.
Okay, I'll just share my PPT.
Yes, sir.
Just a second. If you are able to see the slide, then I think I'll start my presentation.
Yes, sir. It is visible, sir.
Yeah, great afternoon to you all. It is my pleasure to be part of the faculty development program, which is hosted by the prestigious Institute Geetanjali Engineering College. And it has always been our pleasure to share whatever we are doing as part of my research and consulting research development program. Just before this seminar, I would like to tell 2 important things. Whatever work which is being projected here or being presented here, it's been a part of our own research group, PhD students, and as well as my co-faculty. So this is from past 3 years, we have been developing one of the research center called Center for Sustainable Infrastructure and Systems, which has got 2 components. Majorly 2 components. One is use of artificial intelligence in health assessment and monitoring, which is led by Professor Prafulla, who was working with BITS Hyderabad previously. She's from computer science, and I am heading the infrastructure part, in assessment of infrastructure part. So we both have started this research center. Currently, we have almost like 15 to 18 research students who are working, and we also have around 6 PhDs, 2 full-time and 4 part-time, not part-time, external PhD students. So Center for Sustainable Infrastructure and Systems started in 2017 as soon as we joined here. And then we started to collaborate and did a lot of works. So largely a small note on this one, it also comprises of live case studies This you have to remember that the live case studies are being showed to you because they are part of our experience, and we have not fully completed all these projects. They are ongoing projects, apart from few master projects which have been presented in India and abroad. So note, so a lot of this presentation is not been actually taken from any books or from any consulting companies. This is all largely based on our thinking and whatever case studies which we have visited during our last few years of time. So outline, in fact, people are really healthy. People are weak in health. People need to consult doctor. They have a lot of problems as a people. Very similar to that, we also feel structures have got their own problems. Every structure is designed for a certain age, like a human being. An average age can be from 60 to 100, based on different geographical regions. In same way, Indian structures are also designed for a different age. Like if we take an RCC structure, then they are designed to 80 to 100 years. Whereas if we take historical structures, some structures are designed for 400 years to 1000 years based on stone and kind of binding material. So then we were thinking on various Indian infrastructure, and we were thinking on its health, which was largely missing in today's education. And then that can be either historical, that can be a transition, because transition, it always happens that there's always advances in materials and structures undergo a lot of transition. And there's something called health. When we go to doctor, they have different types of tests. One is when he sees the patient, he tests with stethoscope, and there are other advanced laboratory tests. So we also deal with such kind of three kinds of techniques: traditional, and sensors, and advanced. So putting all this, we were really interested in understanding, is India healthy, especially in terms of infrastructure. So then what we understood is civil engineering is not enough for us. Engineering is not enough to understand all these structures. The first and foremost thing is we need to understand science. For me, science is very different. We keep a simple sentence: is science is understanding the nature as it is. It's a fact. So science is more about facts. So trying to understand as it is. And largely, science can be understood by eyes, ears, nose, tongue, and all skin and touch, and laboratory experiments. Like one of the basic science what we do in civil engineering laboratory is the compressive test for any concrete cube. So what we get as E of material property is a science. It's not engineering. Now, how do we test is an engineering. How fast we can do is a technology. But anything material property is all about science. How do we test is engineering. How fast and accurate we do is most of technology. So we have science, engineering, and technology. To understand structural health, it is mandatory that we understand this science, engineering, and technology. So let me go forward. Like, I don't know, there must be various number of students, which is faculty, and also a couple of engineers who might be doing in some of the consulting work. So with great respect on all of you, I was also one of them when I joined my Usmania University in 1999, finished my engineering in 2003. So I was also dreaming to be a part of one of the biggest largest projects in the world. I think I hope civil engineering, everyone's have that. So largely, what I was taught, or we were taught was a structure to plan, do the analysis, and we see the complete installation or implementation of the project. We always wanted to be part of these special projects, right? Even today wanted to be part of these projects. I would like to be part from the starting to the ending. So, and also we also think about sustainability of these projects. Let me come back. So there are various structures in India which we were trying to understand. Like when you see these three structures, One is Akshardham, which is in Delhi, completely made up of stone, sandstone. Right side is the Infosys building, which is made up of fiber and glass. And bottom is Chhatrapati Shivaji Airport Terminal, which was actually inspired, and it is also called biomimic because the columns are not real like circular or a square or rectangle or any other, but it looks like a tree, so which is actually inspired from nature, so called biomimic structure. So what we did learn, actually I said, planning of the building, analysis, analysis,
Yes,
and then design, and then execution. If any problem in seeing the screen, please let me know.
Sir, please share it on the full screen. It is not visible on the right hand side corner only. It is.
Okay, just a second.
I request all the participants to ping Dilip Kumar for presentation. Please ping Dilip Kumar for the presentation.
Yeah, now can you see my presentation?
Yes, sir. Yes, sir. Now it is coming. My humble request to all the participants, please permit the speaker to present. Afterwards, we can have any questions or discussion, please. Humble request, please, to all the participants.
Yes, sir. Yes, sir. Please.
So everyone is able to see the slides?
Yes, sir.
Yes, yes. Now it is visible.
Okay, then I'll go forward.
Yes, sir. Yes, sir.
What did we learn in engineering was planning, analysis, design, and execution. So this was largely taught at undergraduate level. But what was missing is until we see the structure. Okay, now do you really think this structure is healthy? So we have been seeing a lot of these structures. Sometimes these are called extraordinary in design, and this structure maybe they are excellent in design, but are these structures healthy? So who is that person who is responsible for design of such structures? And if something happens to this structure, who is that person who will be able to tell what will happen to these structures, especially during the extreme conditions like huge cyclones or earthquakes? So what was largely missing in the curriculum, which we found was either in undergraduate level or master's level, was maintenance. We don't have doctors who can really understand the structure. We are all very good in planning. We are also excellent in analyzing and design. And then we see that the structure is actually implemented. But there are certain shortcomings, challenges during the construction of the structure. So after 10 years of construction of time of any structure, due to various reasons, the structure might deteriorate. So how do we tell the health? So that's what this whole presentation is all about. So civil engineering deals with the civilization, building and maintenance. So it is not only about the till implementation, it is much more than that. That's a maintenance. And we have seen that normal residential to extraordinary special structures. All the structures around, according to my understanding, more than 50% of our structures are suffering from either slight fever, cold, or cancer. We'll see behind these things. So anyway, historical structures, Gateway of India, this is completely made by stone. It's light bending material, interlocking mechanism. It is very good. But right now we have a vehicular vibrations. There are slight vibrations because there are too much of vehicles and because of ships. There's something is happening to the structure is the question. And there are forts, there are too much of public always running around here and there. Vibrations are there. Anything is happening to the structure is a question mark. And then similarly, there are temples. So question is, all these structures are very good for watching and they are excellently very well. But when we when we see actually vibrations, there is certain deterioration in the structure. There actually joints are failing. That's what we actually observe. So these are different structures and the historical structures. One case study which we have tried to understood was Ramappa Temple in Warangal. So they say the foundation in 1957, 1959, there was the last earthquake. a kick one of 5.7 to 5.9 magnitude earthquake, and see that the foundation of this Ramappa temple has got affected. And even if anybody is visiting today or tomorrow or in future, you can actually see the foundation of this structure has been affected. The question is, how do we rebuild this? Or it's not rebuild, actually, how do we tell the structural integrity or structural stability of such structure where already foundation has been settling from many years? This is a big question mark. So there are certain columns which we have seen. You can see this. People are finding it difficult to put back them into the actual place. And there are many other historical structures which have actually failed. Question is again, are there any engineers who can put back and tell a methodology to see that these structures are put back into their original shape? And there are certain transition structures which we really like and which we have seen in Manali, Arunachal Pradesh, Assam, Kashmir. There we have seen during just after 2005 earthquake. Transition structure, they are actually like if there are 3 generations, I always keep as this figure. So there are 3 generations. Grandfather has built his house with stones. His son has built with bricks, and the grandson has built with bricks and wood. So this structure is, even though there are 3 different materials which have been used, this we call it as transition from age to age. So sons did not want to demolish the olden structure, but has built a structure on it. Very similar examples which we have seen in Hyderabad, residential structures. There are many structures which were built around 40 years back, and then on that we go for another floor. There are certain structures which are actually struggling to stay alive. So this is another structures after a few ages of 80 years, stones actually exposed to the atmosphere and they get deteriorated. So this is from foreign anyway. So advanced structures we got, I know you all understand 3 types of structures, even though this lecture is not about that. I call them as load bearing structures, frame structures, and core structure. Core is something we have the actual spinal cord in the mid of a structure, and from that cantilevers are projected on either of the sides. They're called core. So there are 3 different types of structure largely. So India has got at least most of them. If you consider 2 lakh villages, then we have almost 70% of the structures are made up of load bearing, and remaining around 20-25%, almost 28-29% are frame structures, and remaining will be of core structure. That too also advanced. This is precast structures, a new methodology to build a structure much faster, easier, in a short period of time. It does not depend on how many number of floors, but in a very short period of time. There's another DLF which has been building the structures because of green building effect. They use a lot of glasses, decrease the dead load, and they go for the glasses. So daylighting is easy, and it will also reduce the weight on the structure, so optimize the sections of columns of the whole structure. And then there are other kinds of structures, signature tower, and one is actually coming up in Hyderabad, cyber towers, not cyber towers, police headquarters, that is also in a different L-kind shape. And then we have other structures as well, which are also prefabricated or composite structures, which has RCC and steel and fabrication. The question is, again, is India healthy from the structural point? So if you see this image, anybody who has traveled to Mumbai, they can see it's a complete contrast. Sometimes as a civil engineer, we feel that this image actually shows you 3 segmental kind of structures in Mumbai. Like they're all below poverty. This is all sheds which are actually built with stones, brick, and also certain steel sections are asbestos sheets. So you can see this one, and just after the sections mid, you can see the apartments which are around 40 to 45 year old. You can see that age, they are deteriorated. Maybe the whitewash has been gone, and you can also see, I don't think you can actually see the minor cracks, but there are also minor cracks in that structure. And the back of the structure, you can actually see a new upcoming apartments which are around 15-year-old to 20-year-old. So you can see these structures, there's a contrast in it. So these short structures are very risky for cyclones. Mid structures can fail at any point of time if they are not tested. New structures seems to be healthy, but we don't know whether they can stand for an earthquake or not. So this is seen in BBC. You can actually also go through the YouTube video. I would not show the video in this part of lecture. We were in BBC in 2012 and 2013 because only in the year 2012 or 2013 there were more than 100 people killed in Mumbai city itself, and largely because these were deaths all were because of building collapse of structures. So yes, 2013 more than 100 people killed, and up from 2008 to 2000 almost 13 or 15, we can tell more than hundreds of structures have collapsed. Now that is the question: is why are these buildings failing suddenly? When we design RCC, because under reinforcement we call them as they give warning. If you don't consider to a warning, yes, they actually collapse, they fail, leading to the fatalities, human loss. So at more, it's not only the old structures which were actually collapsed, but there were certain new structures which were also collapsed. These things happened in Kurnool, Pune, Bangalore, Delhi, and one of the building has collapsed in Nanak Ramgada just before the police station because they were actually digging for the foundation. So it's not old structures, this is also happening with the new structures. So is it because of our design? Is it because of our maintenance? Is it because of our implementation or execution? What is that which is missing largely, which is making these structures to failure? So as you see in the figure, this is a very new building, and we don't actually build these structures to sit or sleep. We actually build structures to stand tall for at least 80 to 100 years. At least 80 to 100 years. But then we can see here a new building which is sleeping. This was actually collapsed within almost an hour. This is in Bangalore in 2018. Okay, to intensify these doubts, we were traveling all over India. We were trying to understand how the structures are. Let me show you a couple of pictures which we have taken it from all over India. This, I went to Calcutta. When we went to Calcutta with our team, which we have seen, if you can see the structure, it seems to be like a green building. But believe me, all these structures, this structure is largely built with stone and mud and light lime. And you can see a lot of trees which are growing on the structure. Few of the scientists believe that trees roots can actually strengthen certain part, but these can also make voids and cracks in the structure, making the structure weak. So if these things continue, then structure will deteriorate much faster than the design life. In RCC structure, if you put water, 80 years of life can be reduced to almost reduced by 40 or 50 years. Structure will fail at the age of 30 or 40 or even 25 as well. So you can see the intents. This is brick and lime. You can see the intents of plants or trees. Generally, small grass is okay, but a huge trees. This is not roof gardening as such. What you're seeing is not a roof gardening, but they were actually growing on the walls and slabs. And if you see more clearly, most of the trees, what we have seen in Kolkata was, most of the trees, plants are growing at the sewage line. Okay, they were actually growing at the sewage lines. And one of the biggest flaw of structure which can reduce the health is the pipeline, sewage line, any water line. So if those can be taken care, actually the age of the structure can be actually increased quite easily. Now this we went to Andaman and Nicobar only to understand how the structures were doing after 2004 Sumatra earthquake, because one of the states in India which was hardly hit, which was very tough for that islands, because tsunami has washed away a couple of islands, and Andaman Nicobar had a huge destruction. So we went there, and this is you can see the power of a tree, banyan tree actually can penetrate into RCC column, and then it can spread its roots. This is not only in Andaman Nicobar. This we have also seen in Hyderabad, and even in many of Telangana and Andhra Pradesh state as well. It doesn't belong to only Andaman Nicobar, but I can only showing the extreme cases. This is one of the building. You can see if a building is left like that, a tree can go over on top of the structure and sit there. This was one of the structure which was washed away in 2004. But then you can see the whole tree has grown on the structure, and it can happen. And if you clearly see, there are a lot of cracks in brick structure, even though this is not full structure. But structures in Calcutta or in certain places of any state, if trees are growing on the terrace or on the walls, if they are left even for 4 or 5 years, that is good enough to have a good number of cracks, structural cracks. So now largely what we have seen is process of deterioration. Now, why do structures deteriorate? Question is, one of the most fundamental is environmental effect that can be freezing, thawing, and summer is also rainy season. And then functional requirement. In Hyderabad, it so happened that many of the structures are suddenly turned out to be a business places, like they actually install telecommunication tower or a billboard. The building is not designed for telecommunication tower or billboard, but suddenly for 5,000 or 6,000 rent, these structures are installed on the structure, okay, without structural integrity or stability test, then these structures pose a danger to the human life as well as other life as well, including the structure's health and any other natural or man-made calamities. There's one small experiment which we have did here. I would like to share with it. If there are two same buildings, which is in one in Balnagar in Hyderabad, and there's another part of somewhere near outskirts of Hyderabad, then the structure which is in any industrial area will deteriorate much faster, because industries release acidic gases into the atmosphere. When these mix with the atmospheric water vapor, they react with the structure, forming much faster deterioration. You know, acids deteriorate concrete much faster. So what happens in the industrial areas are structures actually deteriorate much faster. So special steps have to be taken care. This is a proven, because we've been doing a lot of experiments in and out in Hyderabad. So to understand the current structure's health, it's always a challenge to how to measure what is the health of structure today. As a human being, we do the angiogram or cardiac test or running test. There are a lot of other tests. We take to any diagnostic center, we do some around 4 or 5 tests. Largely, they check with heart and kidneys and breathe, and they can tell what is the health of a human, like BP, sugar, and other things. Very in similar way, we also have a couple of traditional techniques and sensors and advanced, which can tell the health of a structure. Now, let me tell you, if you are seeing the picture, the person who is actually carrying a hammer in this one on a railway track, you have to understand that there are almost 2 lakh employees working on contract or daily regular basis with railways. They actually take the track. Now we are trying to develop a software which uses artificial intelligence to check the track. So if you actually hit with a small hammer to the rail, then he can tell by expertise whether there is a crack in railway line or not. That's what his expertise say. Traditional methods are always based on experience, and they are one of the best solutions to tell. Even if you hit with your hand or a small hammer any wall, based on the soundness of the voice, sound, you can actually tell the health of the structure. And other front senses, you actually put your ear, or you actually use any of your sensors to test the health. And last one is the wireless or wired sensors. So to say this, we did certain all this. There are certain basic projects which we undertook in Mahendra Coal Centrale. Like there are many people who used to say that the brick, the strength of the brick has been changing since many years. So what we did was we took bricks from all over Hyderabad, from various structures. So structures, I'm showing only a couple of pictures, but we took almost from 50 different structures, wherever almost these bricks have taken from 60-year-old to latest brick. So what we have found in our results when we did compressive strength was, even though we have very good bricks today, 60 years back, even though dimensions are a little different, the compressive strength of 60 years back was seen to be much higher. The reason we have to understand is 60-year-old brick is taken from the building and not from the manufacturing plant. So when we take from that building and we did test and we took a new brick, we actually have seen the compressive strength of the old brick is much higher. Question is to us, what has happened in all these years that compressive strength of that brick remains same, and now the brick is changing. Anyway, these are few 20-year-old structures which we have taken and tested. Second, I said that is one test. There's a second one. What we did was this was in 2015 when we were traveling from IIIT Hyderabad to VJIT, Vidyajyoti Institute of Technology, with a few of master students. And then what we have seen was one of the billboard has fallen due to wind. But this is in this picture show in the Vizag. But we took a few live case studies from the Hyderabad as well. Aziz Nagar. Okay, this is near Aziz Nagar when we travel to Golconda. So this is one of the structure. You can see the billboard has fallen. Luckily, there was no casualty. This we have taken from the flyover. And then immediately one of our student, Mrs. Saram, has accepted to do this project. And then we took up this project. So there are two ways of attaching billboards to the structure. One, they actually have this foot, which is made up of a concrete foot. And the other structures, they actually put to the column. So they integrate with the projections of columns and beams. So that is one way. So in this case, in this building, we have actually seen the failure of the billboard. But there was other cases as well where we have seen the vertical cracks in the column. So immediately we took up this one, and we took some 3 real buildings and 3 billboards and communication towers, and then we have modeled, and then we have actually taken the dimensions from the original existing building, and we have taken the maximum wind speed which Hyderabad has taken. So we've taken 110 kilometers per hour. You can see 110 to 120 maximum kilometers per hour of wind, especially at the windy seasons. So what we have seen is, if this is just kept as a foot, definitely billboard will fail. But then if we actually attach to the columns which are projected onto the ceiling, onto the terrace, then what we have seen is, if the area of billboard is very large, and if there are no holes to the advertisement, then there is a huge movement which is generated on the column. So there's a huge movement which is generated on the column, and that can actually lead to the cracks on the columns. The third one, this is as I said, one of our my colleague, Professor Prafula, was working on digital image processing of cracks. What we did was, we took images of various cracks of our own college, slight cracks which happened on the wall. And these days, engineers started to believe that we cannot actually avoid cracks. But then if our science is an excellent, then I'm 100% sure we can actually build a structure without even a single crack. There can be of 3 reasons: either because of geotechnical, either because of plastering and breathing while curing, and there can be another external reasons of extra load or any other thing. But can largely, if science and engineering are understood, implemented at the same accuracy of engineer, then of course cracks should not be a problem at all. They won't occur actually. So what we did was, we took images of all this, and then we were able to do the image processing. And we have actually developed this app where you can just use with your cell phone, take an image with your cell phone of any crack wherever you see, and then upload it in this app. It will immediately give the crack length, crack width, and crack type. If the same types of cracks are there on beams and columns, then they are called structural cracks. And to understand whether they are significantly structural cracks or any shrinkage cracks or non-structural cracks, then we need to know the length, width, and type. So this app can help us in giving that information. Of course, this is all now the same thing. And now we are inducing artificial intelligence. This was based on digital image processing. Now we are using artificial intelligence to tell whether the crack is actually structural or non-structural. It does not matter whether it is a wall, beam, or column. That can also be used for Indian road pavements as well, whether it is flexible or even rigid. This I will not be able to tell much, because this is an experimental which I used to do when we are face-to-face lecture. Question is very simple. If you have this wall which is fixed at the bottom, and there's a load which is acting at left end, a blue color arrow which you are seeing, and then when this arrow is acting, which is the crack, which what kind of crack which will occur? So the crack will be in 1, or the crack will be 2, the crack will be 3, or crack will be 4. Because if you understand this phenomena, then you can actually tell the building how the forces are traveled from top to bottom of the structure. So anyway, if you have this blue color arrow, right side small images shows how it will deform, and then crack I'm hearing another voice. Yeah, okay. The crack is always perpendicular to the tension. So one is the crack which will actually appear on the wall. Anyway, if you understand that. And this one very recently, which we have said, understanding structural health using piezo sensor. So what we did is we took piezo sensor, which is quite cheaper but very, very sensitive. We have a small bridge which connects two buildings. So you can see the 4 researchers who are jumping, and we have a sensor which is connected to the this is connecting bridge. And one of the most important is angiogram or ECG is something like that. Based on the heartbeat, we can tell how the heart is functioning. In a very similar way, in past few years, especially in the last decade, vibration methods have been become more powerful in assessing the global health of the structure, largely rather than a elemental level. So this is actually done by SERC, Structural Engineering Research Center, Chennai. They are actually doing for Pamban Railway Bridge. They actually kept the sensors on the railway bridge, and they are trying to understand the health of the structure. And these sensors can give us the warning if the structure is actually undergoing more deformations than induced. I mean, more deformations than calculated deformations, and that can actually save lives, especially in public structures. So for the first time, Tamil Nadu is doing that. Now CRRI Central Research Road Institute from Delhi is also doing. IIT Delhi is also trying to do. And since we are collaborated with, we are in collaboration with IIT Mandi, Mahendra Ekol and IIT Mandi, and another company, KDM, which we are also doing for railways, especially this health assessment using wireless sensors. This is understanding foundation of historical structures. We did one small test. Most of people see that it's a mystery that Ramappa temple has been built on something called sandbox technology. And then we have actually replicated sandbox technology with the olden traditional materials like karkai, lime and all. And then we mix this, and we have actually tested whether this foundation can resist earthquake or not. When we did the laboratory test with all kinds of ingredients, and what is good about this material is, as age go on, the density of this material will increase. So lime is one such kind of a structure. You have to understand, when slight lime is mixed with any of this sand, because this was a weak material which was largely clay material there, so which sand was mixed and it was made into your boxes. And then when it is made up of boxes like a chambers, and columns are laid in that boxes, they actually have more rigidity than independently. It's almost like acts like isolated, but even though it acts like a complete isolated, the huge soil which is embedded on the column will also become like a stone over the period of time. This has actually made us little of rigidity feeling and also flexibility feeling, which can take the flood water and can resist the lateral loads. That's the beauty of sandbox technology, which is there. But this was our prediction, which might be different from the regular, which has also been published and also been in newspapers as well, about our laboratory testing on Ramappa temple. And this we did in Japan. Japan structural health assessment of a bridge. We were there in Yokohama National University, and then we were doing on structural health assessment of bridges. Then this is one test. This is Sonus X01. This is a wireless sensor. I'll just show you. Don't worry about the sensor parameters, but anybody is individually interested, they can always drop a mail. I will always happy to share what kind of sensors and what we are trying to get. So this is the bridge. This is the bridge. And then if you can see, there are small wireless sensors which are kept on a bridge. When we keep a wireless sensor on the bridge, you don't need to stick onto the bridge, but like something like double type plaster, that is good enough to just keep there like half an hour or 1 hour. And in 1 hour, we can just sit aside of a bridge, and we can actually see the health of the structure. That's easy. It's very easy. But before that, we do all numerical modeling. So what here it's showing is, blue color are the places where we have kept wireless sensors, and black color is the place where we were actually hitting the bridge, and the pink color where we were actually jumping. So if you can see, one of my friend from New Zealand, he has actually hitting the bridge with a wooden hammer. You should always remember that wooden hammer will reduce the noise. whereas metal hammer can destroy, we can create a damage to the structure. We didn't want to damage the structure, but we wanted to give it a small ambient vibration, which will be recorded, and then we wanted to know the structural health. And here we were jumping with one of my China and Korea friend. So we were jumping. Whenever we jump from a bridge, we actually induce certain ambient vibration to the bridge. And these vibrations are actually recorded. Apart from that, we have also taken vibration from the huge vehicles, Class A vehicles, when they actually travel from 80 kilometers to 100 kilometers per hour. So this is numerical model, which is developed in ANSYS. The same bridge is a composite which have I-section girders and a concrete deck laid with asphalt between its layer. So we did this one, and then we actually tried to find the natural frequency from the numerical model, and then we actually calculated from the experimental level. So when we had from the experimental level, we have started with 74% was our accuracy, and we reached till 92% of accuracy. So basic fundamental frequency can actually give us the health of the structure. If anybody is doing masters or anybody is doing health assessment, they know omega equal to under root k by m. K is stiffness and m is mass of the structure. When we know the frequency, we'll know the stiffness of the structure. So mass anyway can be calculated. So by that we can tell whether the bridge is healthy or not. So now largely wireless sensors are being deployed on major bridges to understand the health of these structures. And we also would like to receive a warning system before they give up or before they fail. So this is, you can see, we can also calculate damping of the system. But damping we already give like 5% and 2%. RCC structures rather largely we go with 5% and 2% for steel structures. But then when we do this experimental testing, we also got the damping of the system. This is the data. You have to understand this is from one of the live which we are trying to do with railways, Indian railways, especially Southern railways. We were supposed to, we were doing for 70 foot-over bridges, like including Secunderabad, Nampalli, Khairtabad, Malkajgiri, Lingapalli, and Mehboobabaad. There are a lot of foot-over bridges we were trying to do. And then in this, there are 4 things which we are actually trying to do is visual inspection and non-destructive testing, vibration analysis, and we do data interpretation and data analysis. Just before showing the coming up slides, if at all, please do not share the slides because this is still ongoing Indian Railway project. This is under preparation of report. But I really thought 2 or 3 live projects will always be interesting because this is what we are actually trying to do now. So most of you might know the analysis and design when the structure is not built. But after the age of 20 years, how do we do analysis and design? That was a challenge for us. So visual inspection, anyway, I don't want to tell. Visual inspection is just you have a magnifying glass and you have basic equipments like hammer, and then we go and see. So this is one of the railway bridge. I didn't give the name. Foot-over bridge. Whenever you go the next time to any of the railway station, try to just look at a foot-over bridge from the structural point of view. So when you actually walk on the passageway, you will see the small corrosion on the sections. Now you have to see whether this is a primary or a secondary section. But we were trying to measure what is the corrosion in it. That was the whole challenge for us. So how do we measure the corrosion in such structures and tell what is the amount of loss of that structural member, and how do we retrofit it, if at all, if there is any kind of damage. That's the whole project was with Indian Railways. Okay. Now there's another few challenges which also pose. This is not these pictures are not from mine. I've taken it from net. So these are some places which are accessible and some places are not accessible. Like here, you have a huge high voltage wire line which is going. So it's highly difficult to go at the bottom and look at that top. But we can always use DSLR cameras of high DPI, high pixels, and we can change. Actually, you can see the clear picture what's happening at the bottom. So this is inaccessible places where we actually go and see the bearings with the help of a ladder. And then this is another thing which is called mobile bridge inspection unit, which we have also used to inspect certain bridges in the national highways to see how the gutters are and what are the different types of failures. Especially when there are minor cracks which are visible, then we actually go and see what is the depth of that crack, width of the crack we measure by using this mobile bridge inspection unit. This is also another a mobile bridge inspection unit where you have 3 degrees of freedom. It can rotate at 3 places, and it composes of simple truss where people can actually go on it and they can do NDT testing, because people have to stand on it and take the core. So we do NDT testing. And then this is also something like this. This is also 3 degrees of freedom structure. Okay, now we have something drones. We are also using drones now. Or like there were certain pavement failures, or there are certain bridges. We are currently using drones to see the non-accessible places, because drone is much easier, economic, and irrespective of whatever the weather, we can use drone. Only thing is, if images are not proper, we have to clean the camera and get the images once again. So, but this was much easier for us to take the pictures, and we were trying to do from visual inspection. There are very good drones which range from almost 80,000 to 4.5 lakh. One of the best, we get it for 1.8 lakh drones. They take video and high-end resolution pictures by which we are able to assess the we are able to do the visual inspection. So real pictures of the bridges and railway I have not kept because of certain reasons, but yes, we have our own images. This is a DSLR camera and drone which we actually use to check the bearings. If bearings fail, then the impact of vehicles will be much more, and vehicles will also lose its own shock absorbers. So it is mandatory for us to check bearings. Apart from that, there will also be failure in expansion joints. So bearings are very, very important for any structure's health. So there are certain NDT methods which are taken in the steel structures. Now, why did I actually include this in this presentation is in India, there are many consulting companies which are doing structural health assessment of concrete structures, but it is highly difficult to find a consulting or any company or a research center which actually does health assessment of steel structures. So, and there are even lesser consulting companies which do health assessment of heritage structures. In fact, we are doing 3 RCC structures, steel and heritage structures. In fact, now the ongoing heritage structure is Molali Kaman, which is being tested by our own research group for JHMC. And apart from other few historical structures we are doing. Like in NDT test for steel structures, we have something called liquid penetrant, and magnetic particle, ultrasonic, eddy current, and radiographic. To put it to you in a simple, let me not read the text. If you are able to see this image, which kind of a cat, what you're actually seeing is the actual structure. You're actually seeing the skeleton of that one. You're actually seeing the muzzle part. You're actually seeing the thermal part. Now, when you do NDT is largely to understand what is happening inside the structure rather than what is on the upside. So that we call it as stress. Stress is always about internal phenomenon, not the external. External is always, we call them as a load, because which we can see and calculate. Anyway, stresses can be calculated by external measurements. So these NDT testing, which are called non-destructive testing, we understand the internal behavior of the structure. How good are they? Are they homogeneous, or do they have voids? Are they having cracks? Or what is that which is happening in the structure? So I restrict myself to steel structures. So this is liquid dye penetrating testing. Either anywhere, all you have to do is you take this liquid and like scent or like sanitizer, you just have to brush it on any of the surface, and you can actually see the cracks on metal parts. It is not only steel, any metal. This is a radium green color, which you are able to see is the radium liquid dye penetrating, which can be used on steel. So red color, this is simple liquid dye penetration. So this is also done for steel lining of turbines, and as well as all the steel structures anywhere. So this is the crack indication. Whenever we see there is a crack, then you can see the crack indication. Of course, cracks can be dangerous, especially on the bridges, and we can see this is because of fatigue. Magnetic particle method is something instrument like that. You just have to see this, and then you can also put certain magnetic particles, and then the orientation will tell where the defect is. So these are also tested for welding. Largely, this is used to check the joints between joints in any of the
Questions?
any of the
మనం
steel
చదువుదాం
structure.
ఇంకా
Ultrasonic is largely for homogeneity of this one. If there are any internal voids, any gaps, any cracks, immediately ultrasonic testing can tell us.
ఈ సెషన్ కి
This ultrasonic thickness gauge, by the way, this image is our own image for Indian Railways. What we do is we have to do the brushing and then we have to get the thickness of the effective material. So we were actually trying to do with the ultrasonic thickness gauge to see, we brush off all the corrosion on the top layer and we see the effective thickness of the element so that we can tell whether it can take load or not. So this is coating thickness gauge meter. Every 3 years, every 5 years, whenever we have a maintenance, these tail sectors are painted with a silver anti-corrosive treatment. And whenever this has been done, every 5 years, the layer thickness will increase. So we wanted to know what is the actual thickness of the paint. And then so that we can actually wanted to know the actually effective thickness of the element again. So this is, we were trying to do in one. So it can tell almost 500 microns to 600 microns. If you can tell even 1 mm or 2 mm. So this is Sirpur railway station bridge. As I said, first visit, what we do is we don't have any as such that plans and geometrical properties of 40 or 80-year-old bridges, 80-year footward bridges. So in visual inspection, we get all the geometry data and all the defects. We do the condition mapping and we are actually telling whether footward bridges are good in health or not. Because in 2018-17, there were a couple of footward bridges which are failed. One in Mumbai has led to the project to test all the footward bridges. So we started this. And then there might be seems to be good, especially from the far. So don't worry, all these are being treated now. Most of the footward bridges are being treated now for whatever reasons they have been not maintained at certain places, not all cases. So major stations, they are maintained well, but there are certain stations that were not maintained from past 5 or 6 years. And especially at the coastal places, corrosion is very, very high. So the maintenance will reduce down to 5 years to 2 years. So here in this picture, you can see a lot of corrosion. You can see the spalling. So this is one. And you can see the spalling of staircase and the. So it's easy because you see the mud tiles on the stairs when we go up, but at the bottom they can be really dangerous with exposed reinforcement. And luckily here the reinforcement is not highly corroded, but stirrups have failed, they gave away. This is another railway station. See, that's what I've told. Whenever you pass on the passageway, for you the corrosion might look like very small when we look from a far away, but we actually took a closer view of that one. Now this is the right side images are zoomed images. You can see the bottom part of eye section. Bottom of eye section is corroded on the top. Now it's a primary element, major structural element. So that we cannot see that it gets corroded. We have to avoid such kind of a corrosion because any time joint can be failure. There are always two challenges in steel structures. One is buckling and another one is joint, because they are always slender when compared to RCC structures. So these two are very, very important. And mid of the section, because that will undergo deformation, large deformation. So these corrosion can really lead to sudden failures. This Khairatabad, anyway, this has been repaired, by the way. People are looking at that one. Not to scare you. So whatever data, NDT data we get from the site, we actually get all the corrosion data, we get the thickness data, and what we do is we implement that in our numerical model. And then after implementing the numerical model, and then we test for today's load carrying capacity of the structure. Now today, currently, Railways is taking up with 5 kN per meter square is the load which is all the footward bridges are being designed. Like in Secunderabad, if you see from the platform number 1 to platform number 6, we have the very old bridge which is built 80 years back, and all the joints are riveted. Each you can see in Secunderabad and in Nampalli and as well as in Kazipet, Warangal. But in other stations like Lingampalli and all, we have new bridges which are having either welding or bolts. So largely we see three, either it is rivet or a bolt or a welding. So 3 types. Now we are largely using welding and nuts and bolts for easy maintenance and part. So we do the numerical testing, and then we actually tell railways whether this foot-over bridge can take the load or not, or we need to do any kind of retrofitting. So this is modal analysis. We compare with vibration analysis, and when we see global strength of the structure, and we're also checking the vibration. As such, till today, there is not extensive research or any single line saying that this bridge has got vibrations which are in limit. There is no such kind of a study. Somebody is really interested in doing PhD and such kind of a studies, because there is no bridge in anywhere which will not undergo vibration. If you want a very good vibration, if anybody lives in Hyderabad, just go and stand on Tarnaka Bridge or Lalapet Bridge or Kukatpalli Bridge. You just go and stand and see the kind of vibrations you feel, especially when vehicles go. But when you feel these vibrations, we need to know whether these vibrations are in permissible limit or not. No, there are no studies on it. But then only logical answer will be to see with its frequency, so that the actual frequency of the structure will not match with the vibrations induced by external loading, like any truck car. Because if they match, then one of them will fail. That's called resonance, by the way. And then this is another kind of vibrations. I'll just pass through it. So these are different types of corrosion which we have found. And we have also found there were certain joints, nuts and bolts which were failing. And there are certain contact which has been losing. So this is in continuation to that. This is also, there are certain, you can see the nuts and bolts and the kind of corrosion they have been undergoing. Because as I said, in Mumbai foot-over bridge, the major failure was this. One of the segment has failed. So people have died, 8 people, they say actually it's 11. So many people are being died because of the infrastructure failure. But this can be avoided if these images can be seen and understood what is the kind of damage. That's why now visual inspection and drones are really helping us a lot, much faster inspection and faster remedy. So these are other kinds of images. You can see a small kind of you can see in Nampally. You have a slight grass which is growing on the side of passageway. This is not grown by us, I mean railway authority, but they are just grown by any birds dropping and all. But these can actually lead to the higher corrosion of the members, especially structural members. And at the bottom, we actually even observed there were certain these are precast panels which are kept as a slab panels, and there were certain failure in the mid of the panel. When there is a failure in the mid of the panel, we can say that there is some problem with the joint, because until the joint will expand or it will undergo deformation, panel will have this such kind of failure. And the left side, yellow color shows there is a joint failure. You can see the detachment of joint. This is called trestles. This is also called pitting. Pitting is somewhere spots you will see the corrosion, and because the actually water flow from top to bottom, water stagnates at joints, and that will actually lead to the corrosion at such kind of a places. Again, a green foot-over bridge, but then this is grown by itself. This can lead to moisture there and can lead to the corrosion in long runs, like 4 or 5 years. This is an accidental hit by any tractor. So whenever you have a good stain and all, this trestle, if it is a hit, that's what the question is. Whenever, every year there is a fish medicine which is being given in the Lal Bahadur Stadium, and lakhs of people flow to Hyderabad, especially when there are trestles or something like that. Then trestles will buckle away. They give away easily. So these accidental hits by trucks have to be taken care, at least whenever we are going to have a peak load. But these things are being tested and also considered. So you can see the kind of damage. You can see the complete sacrificial plate has been eaten away, right side image. And corrosion can be really worst enemy to steel structures. And one of the most important thing is the joint in steel structures. And I always tell, my guide is used to tell, whenever we have tendency of copying assignments, we also have a tendency of leaving joints of steel structures somewhere in real world. So we know joint is one of the most important in steel structures, and what if that steel joint is not being taken care. See, there are no nuts and bolts here. I said this is not. I'm not trying to complain on anyone, but these things are being done, and now these things are being seen, and they are all actually being corrected.
ఇప్పుడు
If I have 5 more minutes, do I have some time so that I'll continue another 5 or 6 slides?
yes sir, yes sir.
Again, I don't like to show a lot of text on it. So this is one of the project which we were doing from NVLN. We have inspected more than 450 bridges in the northwestern part of our country. So anyway, there are some segments I don't want to get. 450 bridges. You can see the kind of images. See, left side, the pier is made up of stone and gutters. Right side, now all these bridges are under functioning. And you can see the railing has failed. So on top, it's excellent to go on an Audi or a BMW at the speed of 120 km per hour, or even a truck with the extra load on that bridge. But then again, is this bridge healthy? Again, it's in how can we tell the whole bridge healthy? There are certain things which we can see, but there are certain things which we cannot see. They are internal. So you can see this. This is at the right side corner. You can only see the pier wall. That is actually, it is being scored by every year monsoon season. Whenever there is a monsoon season, we have a huge water which runs down there, and this is called scouring. So it should remove this. And this is our team. We were with the NVLN, and there is another team and government team. So National Highway Authority of India. What we have seen is the foundation of the pier wall is being exposed, and reinforcement is exposed, and reinforcement is corroded. Now, and at any point of time, this can be a hanging and can be the 10th wonder, but only the 11th wonder will be an accident. Yes, there is sometimes this can also happen. This happened during one of our visit. One of the engineer has said that here the road is actually behaving like an elastic, and then immediately they have removed, and they have seen that the actual reinforcement which has to be kept in the slab has not been kept. So that's why the slab was acting more like an elastic, insufficient reinforcement, which was there in the box girder. So this, I don't know why it happened, but it so happened in Gujarat. So happened. Anyway, so there were a few other bridges which were 60 to 70 year old. They are very good, but there are some 20-year-old structure. They are very bad. So we cannot tell which structure is good until and unless we do certain NDT or vibration tests. So you can see the kind of voice. These we call it as, this is not a fever, this is not even a cold, this we call it as a cancer of structures, because a lot of reinforcement is exposed, stalling and reinforcement has actually given away. So this is called cancer. At any point of time, this can fail. So you can see right side, whether it's a pipeline or electrical line, if we have expansion joint, whenever we have this one, huge honeycomb joint, and this can lead to a larger cracks and failure. And you can see here, all these bridges, as I said, are in the functional. Right side, 2 are minor bridges. You can see the kind of stalling which the structures have undergone, and whatever reinforcement it is there for the slab is highly exposed and largely corroded. So they actually become brittle, and they can fail anytime without any warning if measures are not being taken care. Anyway, we had used rebound hammer, ultraponic carbonation, tech stack, chemical corrosion. There are a lot of other bridges we have did. This is almost this is first set of 150 and another set of another 250 which we did. This was NVLN team. This is our team. Anyway, I'd like to get into another one. This is just to all those whenever we do analysis design with the current existing strength, then we recommend strengthening or retrofitting or repair or rehabilitation or refurbishment. They all are defined in a very peculiar way by a small difference. So this is steel plate bracketing. Whenever we need to have higher loads, if load coming onto the structure is higher, we do either encasement of the columns or the plate jacketing. This is plate jacketing. This is done by NVLN company. This is, anyway, they're preparing plates to anchor to the column. So you can see here, plate is being anchored to the column. There are a lot of bolts or shear connectors into the column so that the actual load is transferred to the steel plate as well as column. You have to confine in such a way that the load is taken by both the members, steel and concrete. This is another, this is in Hyderabad, ESI hospital. There's a lot of failure in beams and slabs and columns. And then the loose material has been chipped off, corroded steel has been removed, and new steel has been kept and welded. And then there is a Faber FRP polymer and mesh grid, and then they did grouting and shotcreting as well. So you can see that all the loose material has been removed, and we have provided an extra reinforcement of vertical boards and stirrups kind of thing for extra confinement of that old column. And then we have kept shear reinforcement. Encasement has been done with micro concrete. And this is for the beams and slabs. The same thing which is also been done for beams and slabs as well. This is mesh, grid mesh, and then fiber mesh, and then shotcreting has been done for the slabs and beams. So this is done for one of the pharmaceutical company of Hyderabad. When one of the beam has given away, there was no place to do shotcreting, or there was no place to remove the old material. So the cracks were actually done was FRPs. So slight removed upper layer. This is done, and FRP is being laid onto the beam. So this we had to do because the company cannot shut down its operation, and the place what we had was very short, so we cannot project the beam. Already it is one of the laboratories, so carbon fiber reinforcement polymer was advised, and it has been taken. Anyway, what I wanted to say you is this: whatever has been presented is largely from the research and consulting research we are trying to do. We don't do pure consulting, but research consulting, which is with some kind of research. We take it, and we take it as a case study, and we do the complete health assessment of it, whether it is a visual inspection or NDT testing and numerical modeling until recommendation. We wanted to do for all kinds of special structures. So the journey of understanding structures for our research center has just begun. So by this, I would like to end my lecture. In fact, this would not have been possible with our research center team. This is not a pure of my work. This is our work, our team research work, largely PhDs, and as well as settled from computer science as well. So thank you once again for giving me this opportunity. If you have any queries, you can write it in the column or chat box, or you can directly ask. I would be happy to tell anything which I know. Thank you once again.
Thank you, sir, for your wonderful and very informative session. And I request all the participants to drop their questions in the chat box.
Okay, I am also sorry if somebody has not able to see the presentation, because when I actually was presenting, I have not seen these comments. But I think
most of the presentation was visible, sir.
Okay.
Unless a few technical issues. Sir, we had the chat box. We have few questions, sir. Two questions in the last.
Sir, or else, do you want me to read out the questions, sir?
I think what is the scope of health monitoring of high-rise structure with sensor-based technology? Currently, there is a 100-story building which we are been part of in Delhi, and all the structures which are higher than 40-45 meters, it is mandatory by Indian government that they have sensors installed in the structure, because Delhi is prone to earthquake as well as high winds. So high-rise structures, sensors is as it is must, especially tall structures. This area is very, we don't call it as a new, but for our country it is new. Very few companies are there. It's a huge scope in this one for sure. So high-rise structures, it is must right now. So what are the NDT techniques applied for SHM for railway tracks? We all know for RCC structures. NDT test, I think I have tested. We have been magnetic particle method, ultrasonic testing. We are not using gamma radiation, X radiation. We have to use, but we are, because of the
busy ఉన్నారా?
radiation effect, we are not doing that. But other ultrasonic
Join
test,
అవుతారా సార్?
penetrating
Session జరుగుతుంది.
these NDT 4 NDT test, we are doing magnetic particle method or eddy current method
మీరు జాయిన్ అయిపోయారు.
for railways. Apart from that, we are also doing accelerometer vibration test. That is also helping us to get to know the natural frequency of the bridge.
ఓకే సార్.
After retrofitting, how to assess the strength of the modified one? Yeah, one of the good question is, even we were also faced a similar kind of scenario. You know, whenever a building is being constructed or bridge is constructed, we take the cube test and we do that in laboratory. But the cube strength is way different from the actual strength test. So if you are doing with vibration testing, it does not matter. We can tell the health of old structure as well as new structure. So vibration techniques are excellent because after retrofitting, if we take the vibrations and before retrofitting we take the vibrations, there's a lot of change in the stiffness of the structure that can tell us whether the retrofitting has actually helped the structure or not.
ఆస్క్ టు జాయిన్ ముందు ఆస్క్ టు జాయిన్ ఒకటే కొట్టండి.
Okay. NDE will also use in SHM. Non-destructive evaluation, yes, of course. See, SHM, you have to understand, structural health monitoring is on the global scale of the structure. We'll get the stiffness of the whole structure. We are trying to understand the whole structure. Whereas non-destructive testing or evaluation is done for a part, at element, at very local level. So NDE cannot give us the global picture. It is only an assumption that it continues similar behavior. But whereas SHM will give us the global picture. But anyway, currently today technology, we cannot depend only on SHM or NDE. If they are vice versa supporting each other, that will be excellent. Maybe in few days, maybe in couple of years, like 4 or 5 years, I'm sure that SHM will be, sensors will be good enough to tell the health of any structure.
రైట్. ఇప్పుడు చేయకండి సార్, అంటే సెషన్ అయిపోయాక మీరు ఆ ప్రెజెంట్ నవ్వు కొడితే మీరు డైరెక్ట్ స్క్రీన్ షేర్ చేయొచ్చు.
Yeah, if anybody has, we have another 2 or 3 minutes for sure.
ఓకే సార్, అయితే అసలు ఇబ్బంది లేదు సార్. డన్ సార్ అందులో అక్కడ.
Are you able to hear my voice?
రైట్ సార్. ఓకే.
Yes, sir. Yes, sir. It is audible.
Okay. Yeah, I think we have. Can you put some light on SHM conducted in Pamban Bridge? Structural Engineering Research Center, you should know, SARC is one of the topmost research center in India. They actually work on all kinds of NDT testing and also sensors. They are actually doing with Pamban Bridge. They actually kept the wired sensors there, and they are monitoring it. And they have not concluded anything out of that, but this is one of the bridge is being tested for the research purpose. And they are also trying to understand the vibrations due to different rail engines which are going on it, but they are doing it. But CRRI Delhi has done for few bridges, and with that assessment with using sensors, they have also recommended few retrofitting techniques for bridges, especially post tensioning. Okay, we have another. Do these NDT will helpful to overcome the structures? I didn't get you. Do these NDT will helpful to overcome the structures? See, NDT tests, if are being done, even we also do a lot of NDT testing. They can really give us a certain picture on health of the structure, especially UPV, ultra pulse velocity, and then performometer. They can also give us certain picture on the health of the structure. Okay, there is one more question. Sensors are fixed in a structure before or after construction? Yeah, for new structures, we can have embedded sensors like few of IITs, and we are also trying to do some research on it. Few sensors which are connected by self-induced batteries can be implemented in the structure during the construction. So they will actually tell how the concrete strength is increasing and how the structure is responding to various load during its lifetime. So all these sensors can be designed for 20 years, can be incorporated during the construction. But then structures which are already existing, for that we cannot put sensors inside the structure. So we put sensors on top of the structures, and then we get the health. Okay, among the different NDT tests, what is their reliability with reference to actual? This is one good question. See, one of the good company, one of the best company in world, they say Project. We always have fight with Project people, because Project always says their instruments are excellent in laboratory and for validation. But when we go for the real site, Project hasn't always been, it's not Project, any company NDT tests are always challenging. Like Rebound Hammer, not many people actually even believe in Rebound Hammer, even though the test is used. Because until Rebound Hammer, we generate our own curve for different cubes. We cannot use Rebound Hammer as a base test. But ultra pulse velocity, like proformometer, and we have a carbonation test or any other test are very good. They are accurate by almost 80% to 85 percentile, because we take an average of 3 or 6 samples always. NDT tests are good enough to be reliable, by the way. But as I said, they are local. Yeah, any other doubt? I've shared my email ID on that. You are always welcome to drop by any queries. Feel free to that. Mahendra Ekul Central, you can just find our name and all the details related to it. So again, if there are no questions, I would like to thank Professor Prasanna Kumar Garu to giving this opportunity, and a special thanks to Ramchandra also, who has connected me to Gitanjali College of Gitanjali Engineering College. It was our pleasure to share whatever research work we are trying to do. Hope we have not bored you. This is only live case studies which have been shown. Thank you once again.
Sir, Dilip Kumar sir, thank you very much for your wonderful presentation. It was very, very nice. And it was the real experience of beautiful research with your team conducted over last few years. With real-time photographs, you have shared the essence of your experience in a short period of time. It's really very wonderful. The presentation, as well as the way you analyzed the things, and the analogy given with the simple human health systems, very, very nice and interesting. During the afternoon time, catching the attention of all the people on this is very good. Really, it's a real experience you have shared, and it is very amazing, sir. Thank you very much for spending your valuable time with us.
Thank you so much. I wish you all the best. Thanks for joining, for your patience listening as well. Thank you all.
Thank you, sir.
Thank you, sir. I request all the participants to stay live, because the second session will be starting in a few minutes. And regarding the feedback form will be shared at the end of the second session, which, as I said, which will be starting in a couple of minutes. Regarding the presentation of the presenter, we will try to update through your WhatsApp groups and emails.
పెట్టుకో అరే గౌతమ్ స్టార్ట్ చేయ కావున లేదు స్టార్ట్ చేయండి. దిలీప్ కుమార్ వాజ్ రిమూవ్డా? అరే పాపం ఆయన ఎందుకు తీసేశారు పిక్చర్లు?
Sir, good afternoon, Shiva sir.
Sir, very good afternoon.
Very good afternoon. Thank you for coming.
Most welcome, sir. Thank you so much for giving me the opportunity also.
We are very grateful to you for spending your valuable time with us.
Thank you so much, sir. Can I proceed now, sir?
We'll introduce you for the audience in a
Sure.
1 or 2 minutes. After that, we
Sure.
can start the presentation.
Sure, sir. I hope you are doing well.
Yeah, yes, sir. Yes, sir.
Thank you, sir. Thank you so much.
Uh, Welcome, Shivaram Reddy sir. This is Gautam from Geethanjali Engineering College. I would like to introduce the presenter for the second session, Mr. Shivaram Reddy sir, Director LSB Temerity Infra Private Limited, Hyderabad. So Shivaram Reddy sir has worked in various well-established companies nationally and internationally. He has more than 14 years of rich engineering expertise in detailed design and reviewed engineering of infra projects, high-rise and commercial buildings, multi-modal logistic hub, and PEB warehouses. So besides this above experience, he has also significant exposure on construction and project management services. He has 4 years of international work experience in Oman, Indonesia, Saudi Arabia, Qatar, and Singapore. So Shivaram Reddy sir has also delivered various guest lectures and conducted workshops on civil software to civil engineering aspirants to many reputed colleges, which motivated the student to understand the real skills to be developed in oneself to be hired in the industry. His strength in civil engineering soon propelled him to establish a corporate company named as LSB Temerity Infra Private Limited, which was started purely for the purpose of providing the best technical services in civil engineering industry. So, with these few words, I request Prasanna Kumar sir to say a few words.
Yes, sir. We are very glad to have Mr. Shivaram Reddy sir, Director LSB Temerity India Private Limited. He's a very expert civil engineer and a very down-to-earth practical person. He's got wide-ranging experience in various civil engineering construction projects within India and abroad also. He's very approachable. His explanation to the students is down to earth. Many times he has given very wonderful lectures in our college for our students also. And it is our great privilege to welcome Shivaram Reddy Garu for this faculty development program, for kindly accepting our invitation to deliver a talk on pre-engineered buildings, which is now nowadays emerging in civil engineering, and is the one person who has committed himself to the profession of civil engineering and who is reposing confidence in the hearts of the students, in the hearts of the faculty, and in the hearts of the civil engineering community as a whole. Regarding the future of civil engineering, there is no depth of opportunities for a qualified and skillful civil engineer. That's what he believes, and he is also proving that to everyone. And we heartily welcome you, sir, for this presentation. Thank you very much for joining us.
Yeah, thank you so much, sir. Thank you so much for your great words.
Yes, sir. Now I request Mr. Shivaram Reddy sir to kindly present.
Yeah, can you please guide me how to start doing it?
The already screen is shared, sir. I think Ramchandra.
Yes, sir. Yes, sir.
Can you help
Yeah.
Shiva, sir?
Shiva, sir. మీకు రైట్ సైడ్ కింద ప్రెసెంట్ నౌ అని కనిపిస్తుంది.
Just a minute, sir. I'll close my presentation.
రాజు సార్ ప్లీజ్. ఎస్ సార్.
Okay. Now?
Shiva sir,
Shiva sir.
right side.
Yeah,
present now అనుకుంటాను సార్.
Yeah, 1 second. Your entire screen.
Yes. Sir, your entire screen. అక్కడ మీ ప్రెజెంటేషన్ పీపీటీ ఓపెన్ చేసింది క్లిక్ చేయండి సార్.
ఎంటైర్ స్క్రీన్ క్లిక్ చేసేస్తున్నాను.
ఓకే సార్.
Okay.
That's fine.
Yes, sir. It's come.
Is this not clear?
Yes, sir. Done, sir.
Done. Can I proceed now?
Yes, sir. Yes, sir. You can proceed.
Yeah, thank you so much, sir. Very good afternoon, all. I believe I'm audible to all of you.
Yes, sir.
Yeah, thank you so much. Okay. Very good afternoon, all. I'm Shivaram Reddy here for today's topic as of this FDP program. We are going to have a glance on design of PEB steel structures. Glance on PEB steel structures. And of course, my name is Shivaram Reddy. I'm from LSB Temerity Private Limited. Right. So before I'm going to start our session, just give me 2 minutes of time. I will talk about this organization for 2 minutes hardly. And these are the services when LSB Temerity has started or has been established in 2019 February, and they are the services that we are offering. So we have a services like structural design consultancy, PMC services, construction, and then corporate training also. So these 4 are our primary services we are offering from our consultancy end, right? So this is a team. So LSB, most of the people are used to ask me what is this LSB. In fact, LSB is 3 directors, initials, LSB. So one is Lalita Madhuri, second one is Shivaram Reddy, it's me, and then B is Bharat. And remaining all are the key personalities who are working for LSB Temerity Infra Private Limited. And this is a brief 2 lines about me. So I'm having 14 years of experience, and my experience is completed with this structural design of various kind of industries. And I have experience of designing this RCC structures, steel structures, and of course I even have this design exposure into these buildings, bridges, oil and gas structures, and then thermal power plants, cement plants, and then various structures. Out of 14 years of experience, 4 years I have international experience, and of course this introduction has already been done by respected people earlier. So I'm the host for this session. Yeah, they are the achievements that we had done in the past 1 year. You can say I have 1 year, 3 months hardly. So in 1 year, 3 months, we are feeling proud to say about the achievements that what we have done. So let me say this hospital buildings we have designed, and then semi-commercial buildings, apartments, function halls, residential buildings, and PEB structures, and then 30 floors building review also we had done in the last 1 year, 3 months. In addition to this primary core consultancy services, we also are offering this corporate training, which is offline and online also, right? So in the case of this offline training, in the last 1 year, we had trained nearly 250 members and minimum. And we are very happy to announce that we had trained 1,250 members through the webinars in the last 3 months. So these are all the achievements that we had done in the last 1 year, right? This is a very brief description of this is the brief about the achievements that we have done from LSB Temerity Infra Private Limited. Now let's get into this PEB steel structures, right? So today's topic is PEB steel design. As you know that I think most of us anyway know it. So designing of RCC buildings, I think most of the structural engineers or civil engineers would be more comfortable to design this RCC structure. But when it comes to this designing of steel structures, I rarely find the structural engineers who are dealing with the steel structures. What is the reason of it? The reason here is, so whatever the theory that we are learning from the academics have to be very effectively or can be very effectively utilized in the case of the steel structures. But in the case of the RCC structures, I don't think so. There's a very good compatibility between the theory and then practice. But there is a huge compatibility of what we learn this theoretical knowledge, maybe moment of inertia, center of gravity, and then standardness ratios, design parameters, analysis, analytical skills. Whatever we study from this academics would be very close to this practice when we are designing this steel structures, unlike RCC structures. In the case of the RCC structures, the easiest thing is we hardly find different geometric shapes. Hardly find it. So most of the occasions we find like rectangular sections or square sections or hardly circular sections in the case of the RCC structures. But when it comes to these steel structures, we have n number of steel profiles. We can say I sections, angle sections, channel section, jet sections, C sections, right? Equal angle, unequal angles, and then cold formed materials, right? We have different types of the profiles, and we can even say IPE sections, wide flange sections, right? So there are n number and different types of the steel profiles we have to consider in the case of the designing of these steel structures, right? So there is a very huge difference in the sense. In the case of the RCC structure, I personally, being a structural engineer, consider that would be more easy to design it. But when it comes to this steel structure, that would be more tough. Anyway, for today's session, I just would like to brief you how usually one can design a PEB structures in a practical considerations. Right? I'm more interested to explain the things or to explain the things in a practical manner. Right? So these are all the brief contents or overview of the PEB steel design that we are going to discuss in the next one and a half hour hardly. Right? So before we get into this designing of this steel structure, the first one is design flow chart of steel building. First thing is we must be having an overview idea. What do you mean of a designing of a structure? First thing is, once we come to know the stages or the flow chart which is describing about the steel design or any kind of a designing of a structure, then it would be easy for us to consider any kind of the structure and design them based on the requirement or suitability depending on the type of the structure. Right? The first one is design flow of structure. The second one is introduction to PEB structure, PEB steel building, and then components of PEB steel building, then code books that need to be referred for designing this structure, and the material specification. Unlike RCC structure, even here also material specification. What kind of a material we have in RCC? Only RCC, you can say concrete grade, and of course rebar grade also. In the case of RCC, you can say either M20, M25, M30, whatever the grade of the concrete it can be. That is the easiest thing that we can recognize it for recognizing that. In the case of the rebar, you can say 415 grade of steel, then 500 grade of steel, 500D grade of steel, and then 550 grade of steel. Nowadays, anyway, we are getting 500 and then 500D. Most of the occasions, I am noticing that 500D and then 550 grade of steels are available in the market, right? So there are only two types of the materials. But when it comes to this steel structure, we will be having a different structures. Different structural elements, main frame, and then secondary members. So in the case of the RCC structures also, we have a secondary members. We'll be talking about what is secondary member, what is this primary member, why there is a change, right? Such kind of the things also we will discuss in some time. But right, when we come to this material specification, in the case of the RCC structures, yes, two grades only. One is concrete. We hardly talk about concrete material, and we hardly talk about the rebar, right? Most of us know it. 415, 500, and 500, 550. That's it. But when it comes to this steel structures, no, they are changing. They are completely changing, because we also have a connection designs in the case of the steel structure. When it comes to this RCC structure, RCC is a monolithic structure. It's a monolithic concrete structure, right? Integrated or monolithic concrete structure, unlike this steel structure. So that's why even a structural engineer or someone does a gross mistake while designing it or during this design. To be frank, I don't think so something will really happen to some kind of a damage will happen to your structure, RCC structure. But when it comes to this steel structure, each and every component has to be studied independently or with a thorough attentiveness, with very thorough attention skills, right? Because in the case of the RCC structure, what we do is we have a column, beam, slab, staircase, foundation, and then water tank partly. All these components are integratedly connected, or all these components are monolithically constructed with rebar and then concrete. So there is a kind of a more stiffness, and there is a more possibility to transfer the forces one element to another element, and those joints are very rigid. Column joints and beam joints are very rigid. But when it comes to this steel structures, everything would be more difficult, even from the reading of architectural drawing to the designing them, and to the designing of this main frame and then secondary members, connection designs, even there's splice connections, and there's a moment connections, and the shear connections, and the anchor bolts, right? Erection bolts. We have to have a more theoretical knowledge. Also, we have to have a more practical knowledge in the case of the steel structures design. So that is why, as by my perspective, I rarely find people who are dealing with this steel structures, right? In the case of the steel structures, see what would be the maximum or a minimum thickness of the element. So minimum thickness of the element, we can say 1.5 mm, 2 mm, 2.5 mm. So such kind of the 1.5 and the 2 mm thickness are very negligible when we compare with the thickness of the elements in the case of the RCC structures. In the case of the RCC structure, what is the element which has the minimum thickness? I can say it is RCC slab. I can say it is an RCC slab whose thickness will be around 125 mm or 150 mm. See, the minimum thickness of the structural element in the RCC itself is 125 mm. But in the case of the steel element, the thickness of the elements is, in the case of a steel structure, the thickness of the element, like I can say purlin. If it is a Z purlin, I can say it is 1.7 mm, 1.8 mm, 2 mm hardly. Right. So now we have to just get surprised how the structure or structural component would be able to persist such kind of the loads. So it is very important just to change our mind when we are acting like a RCC structural engineer to act like a structural engineer who is going to deal with these steel structures. So there is enough gap between these two. Right. So in the case of the steel structures, we have only 1.1 mm or 2 mm, such kind of the elements we have in the case of the RCC steel structures. But in the case of the RCC structure, RCC is integrated or monolithically constructed. So there is what I believe is we can rarely find the damage in the RCC structures. Right? And then let me just go to the next overview, next point, that is design assumptions. Design assumptions, what we do, what we have to make in the case of the steel structures are so delicate. So attention and our assumption must be pretty clear in the case of the steel design structures. I mean, designing of steel structures. In the case of RCC structure, don't worry about it. We are just making a frame structure. In any software, it can be a STAAD or it can be a DTABS, and apply the loads and apply all of them, then run the analysis and then start releasing the drawings. That's fine. But when it comes to this steel structures, we have to understand the theory very clearly, and we have to apply those theoretical concepts very delicately in the case of the assumptions before we design or when we are designing this PEB or any kind of steel structures. And then type of supports also. So in the case of the RCC structures, yes. In the case of the RCC structure, some consultants will consider this as a pinned support, some people will consider this as a fixed support. Very technically speaking, as long as we are working on these RCC structures, I don't think so that we will be enough confident about our theoretical knowledge. I don't think so we'll be having enough confidence in this RCC structure designs or on our knowledge that we have gained from the academics. But when it comes to this steel structures, yes, all the theoretical knowledge has to be clearly understood. So type of supports, in the sense, in the case of the steel structures, we would be using different types of the structures unlike RCC structures. In the case of RCC structures, some people consider this as fixed, some people will consider this as pinned support, and everybody has their own I can say judgmental statements. So even sometimes instead of giving this fixed support, even if you can give pinned support, that change of support definitely is not really going to damage the structural stability. But in the case of the steel structure, if we commit any kind of mistake in choosing the type of support, definitely that is going to damage our structure. So I can very strongly say the designing of steel structure is so delicate. And we have to design them very carefully with 100% attentive skills. And then loads and combinations, we will also talk about this loads and combinations, and then other design criteria. So this is a very brief overview of the PEB steel structure. We are going to discuss in next 1.5 hour time hardly, right? Now let's change our slide. See, now it's a design flow chart. So what do you mean of design? Why do we need to design a structure? Designing of a structure is nothing but we have to satisfy these three criteria, like stability criteria, strength criteria, serviceability criteria. In the case of the steel structures, yes, connections are more important, right? So forget about the type of the structure for time being. It is a design flow chart. You can just consider or take this flow chart for designing any kind of the structure. When we see design in the sense, we have to finalize this member section. If it is a RCC structure, we have to finalize the cross section, member cross section, and to provide enough rebar to withstand the analytical resultants that we get from the different load combinations. Right? Load combinations are based on the load cases or loads which are applied on a structure. Again, those loads would be depending on the type of the structure and the structure which is located, structure that is located in a place, right? So now the thing is, design means the basic fundamental thing is designing is nothing but choosing this cross section and providing enough reinforcement to resist the analytical resultants. Analytical resultants nothing but shear forces, bending moments, and then axial forces twisting moments, right? So these are the analytical resultants that we get it when we analyze the structure, right? So once you get this analytical resultants, next thing is you have to now design a structure by fixing the cross section and provide enough reinforcement to resist that analytical resultants for the factored combinations is called designing of a structure in the case of a RCC. The same thing even in the case of the steel structure, same thing in the case of the steel structure. But here in this case, we have only one type of material, that is steel. In the case of RCC, grade of concrete and grade of rebar. Nothing but there is a kind of a composite structure or a composite element. But in the case of the steel structures, yes. So we have only one type of the grade of element, or when we can say it is a we have only one type of the profile in the case of the steel structure, and we need to now fix up the member cross section and choose the type of profile. It can be I section, it can be channel section, it can be angle section, right? Depending on the main element or secondary element, we have to now choose it, and then make sure that that is satisfying these three criteria, like stability of the structure, strength of the structure, and then serviceability, right? Stability is nothing but first the structure should be stable. First, the structure should be stable. Once the structure would be stable, next it should be having enough strength to resist the forces or to resist the analytical resultants. Next thing is structure might be stable, might also be having enough strength, but finally it has to have a durability, right? It has to last for prescribed period, lifetime period, without making without making any kind of a significant deflections in the structure, right? So serviceability is nothing but deflections. We can even say cracking in the case of the RCC structures, right? So stability is nothing but, first thing is, we know there are two criterion. One is sliding criteria and then overturning criteria. Most of the cases, if we can just recollect this design procedure, most of the occasions we do not consider this stability criteria in the case of the building, in the case of the structures design or buildings design. It can be RCC or it can be steel structures, because in the case of the RCC and the steel structures, we have columns and then beams. It's nothing but it is a kind of a rigid structure. It is nothing but a kind of a rigid structure which would be able to transfer the forces from one element to another element through this connectivity or through this stiffness. But stability criteria is more important when we are designing the structural structures or structural elements which are resisting the horizontal forces, especially dams and retaining walls. In the case of the dams and retaining walls, those two elements are supporting or resisting the horizontal forces or lateral pressures, right? So for those two cases, or for those two structural components or structures, it is more mandatory to verify the stability criteria. So that is why when we are studying from the academics, we always talk about, or we will find stability criteria to be considered in the case of a designing of a dams and the retaining walls. And then we will just talk, then we'll find out the remaining bending moments and the shear forces, and then start finding out the thickness of the member, and then start providing the reinforcement in the case of the dams and retaining wall cases. But in the case of the building cases, are we really checking the stability? No in the sense technically speaking we need to do it, but most of the occasions those will be passing because when we are saying it is a structure is nothing but a combination of structural elements. Combination of structural elements or integrity of all structural elements like foundation, column, beam, slab, then staircase, right? So when we have a frame structure like RCs and then steel, columns and then beam combination, then there is enough stiffness and the rigidity to the structure which would be able to resist the horizontal forces. The amount of the horizontal forces that are acting on a structure would be usually very lesser, and such kind of lesser horizontal forces would be very easily resisted by the framing system in the case of a RCC, or of course in the case of the steel structures also. So that's why let's talk about this stability when we are designing the structures. And now we know about this strength, like bending moments and the forces, right? Moments and the forces. In the case of the bending moments, we have a bending moment and then twisting moment. In the case of the forces, we have a shear force and an axial force, which is depending on the response which is depending on the response of the element to the analytical resultants, like bending, twisting, axial, and then shear. So in the case of the in the case of the beams, we know we have to consider the bending moments and shear forces. In the case of these columns, we know axial forces are very predominant. Axial forces are very predominant, and we will consider this bending moment. And we rarely find the twisting moment. We rarely find out the twisting moment or torsion. Again, this twisting moment has been classified into two types. One is local torsion, and the second one is global torsion. So local torsion, nothing but torsion or twisting moment which is developed in a particular element, like due to this cantilever slabs or due to this cantilever beams. Those bending moments will be transferred into the other elements. So those will be usually called as a local torsions. And global torsion, nothing but depending on the regularities and irregularities of the structure, especially which are located in high seismic zone areas. High seismic zone areas like 4 and 5 seismic zone areas. When I have a high seismic zone areas, due to this irregularities of the structure, center of mass and center of rigidity usually would not be matching. Center of mass and center of rigidity would be usually not matching. When the center of mass and the center of rigidity are not matching, then the distance between these two is called eccentricity, global eccentricity. So due to this global eccentricity, the forces, the horizontal forces which are acting on a structure and multiply with the distance between this center of mass and then center of stiffness and then center of center of mass and then center of stiffness. That is called static eccentricity. Static eccentricity multiplied with the horizontal forces would be developing a global twisting moment to the structure. Global twisting moment to the structure. So what I'm trying to tell you is we have different types of the analytical resultants which would have a more weightage depending on the severity for the structural component or maybe for a structure. And then finally serviceability, yes. Once we can ensure the structure is stable and is having enough strength to resist this factored forces or the factored analytical resultants. And the next thing is it also has to satisfy this deflection criteria and then cracking criteria depending on the type of the structure. That is what a serviceability criteria is, right? And then finally, when it comes to this steel structure, yes, we have to be more concerned about this connection design. So depending on the flange to flange connection, web to flange connection, or column to column connections, column to beam connection, beam to beam connection, and then base plate to this concrete pedestal connections. So depending on the type of connections we have, depending on the connection elements, we have like shear connections and then bending connections and then splice connections and then base plate connections which can be done by anchor bolts. See, when we are talking about this steel structure design, we have n number of things to be remembered or n number of things to be considered or n number of things knowledge have to be gained, right? So when it comes to this connection designs, yes, we have to be more particular and we have to verify each and every connection, each and every component of the connection in the case of the steel structures, right? So this kind of complexity is not really there in the case of the RCC structures. This is what a brief discussion about design flowchart. So this design flowchart is applicable for any kind of structure as we know it. So now it's time to get into this PEB structures, right? I believe it is clear to you. Now let me just get into this main topic, PEB structures. Yes, now let's talk about this PEB steel building. What do you mean of PEB steel building? When do I need to go for it? And what is this really making a much difference when we are comparing with this conventional steel building, and what are the advantages with it? And finally, when you come to know all of this situation, we must know how to design it. Obviously, when we are having enough information or when we know the things which are really required and then we are ready with our information, the next thing is we wanted to go for it. Going for it in this case is going for design, how to design it, right? So PEB, nothing but pre-engineered building, right? So PEB, nothing but pre-engineered buildings, right? As we know that we have a rolled sections, I sections and then channel sections, angle sections, all these are the rolled sections. But in the case of the pre-engineered buildings or PEB cases, we have a pre-engineered material. Pre-engineered material, nothing but we have to design the structure, and now we don't use this rolled sections. We don't use the rolled sections which are manufactured. So as per the design criteria, and then we will be finding out the bending moments and the shear forces. According to that, we will manufacture the sections. Those sections are called engineered sections, right? So those sections would be manufactured, and those sections would be assembled and then manufactured and then assembled as per the original design criteria, right? It means we are not exactly taking we are not going to take the rolled sections. It's because those would be sometimes uneconomical, especially when we have a very large spans, right? So that is what the second one is, when to prefer it. Now we understand pre-engineering building in the sense we are not going to use any kind of rolled sections. We are going to use this engineered material or shapely elements. We can even say plated elements. We will take the plates and cut those plates as per the requirement, design requirement, Benoni criteria, shear criteria, whatever it is, deflection criteria, whatever it is. So as per that requirement means we are going to utilize the material very effectively in the case of the pre-engineering buildings. We are not using these rolled sections, first. And the second thing is when to prefer it. When do I need to prefer it? Can I use pre-engineered section for any kind of steel structure? No. Because this kind of economy is important. This kind of going for this pre-engineering building is more advisable when we have very large spans. Right? In the case of the steel structures, I can say when it is like kind of a shed. If it is shed or sheds. Shed would be usually with a span of 20 meters or something else, right? So as I know it, minimum span what I observed in the case of the steel structures would be 15 meters at truss. 15 meters at truss, I don't think so that is very huge. That is a beginning truss. But when it comes to this RCC structure, maximum span itself for residential buildings especially, maximum span itself would be around 6 meters. But in the case of the steel structures, minimum in the case of the sheds would be around 15 meters. So when you go around 20 meters, that is okay. So right, if I am going the higher spans like a 30, 35 meters or sometimes a 50 meters a span, 50 meters a span, 75 meters a span without supports, without support, 75 meters a span. Just imagine 75 meters a span without support. This kind of a pre-engineering structures are important for a maintenance of this aircraft. In the case of the aircraft, we have to have a huge span of 50 to 75 meters without having any kind of intermediate columns or supports. There we cannot use a kind of a rolled sections. There we cannot use the rolled sections. Rolled section would not be sufficient to resist such kind of a huge spans and such kind of a huge loads. Right? So that is where we need to prefer it. First, we understand what is this pre-engineered building, and then we understand when to prefer it. When we have a very large spans, we have to do it. And this comparison with this conventional steel, as we know it, in the case of the conventional steel, we can use the rolled sections. But in the case of pre-engineering sections, we'll be using the plated sections, or we can also say tapered sections. We can use them. We can use them based on this bending criteria, and then based on this bending and then shear criteria, axial forces criteria. We can prepare a shaped profile. As per the design requirement. So that makes the difference between this convention and this PEB structure. What is the advantage? If you can really do it, if you just for larger spans, when you design or when you consider this a pre-engineered building concepts, you can reduce the 30% cost when you compare with this conventional steel building. When you compare with the conventional steel building, you can control the 30% or you can reduce the cost of 30% in the case of the pre-engineering structures, right? Now we know it. It's a kind of a teaser. It's a kind of a movie teaser we have seen so far, right? We understood now PEB, when to prefer comparison with this steel building, and we also know 30% of cost reductions. Cost can be minimized. When we could find the advantage with this PEB structures, obviously we are now more curious to understand or curious to know how to design them, because which is not a regular kind of a structure. Now we are ready to watch movie. Let's go how to design. Yeah, so PEB, and most of us, so when we say pre-engineering building, and everyone's mind strikes to this kind of a warehouse or kind of a shed kind of a structure. But it doesn't really mean PEB is just referring only this kind of a warehouses kind of things, right? So just look at this. See here. So I have a profile. This is the vertical columns, and this is a rafter. As we had discussed a few minutes back, it is more important to understand, to know each and every component which is there in the steel structure. And unfortunately, unfortunately, we have a n number of components in the case of a state structure, which are having a different behavior, which are having different profiles, which are having different shapes, unlike RCC structures. RCC structure, you have a column, beam, slab, staircase. Fine. All of them are anyway made up with this concrete element. Of course, in this case, we have a kind of a C vertical column, and then cross bracing here we have, and then we have here like a side cut. I can show you the components in the next picture, but just see here. So we have a vertical column, and then rafter, purlin, side cut, cross bracing, sag rods, gantry girder, right? So these are all the components which are here in this picture, right? Let me just go to these components. Before we begin into this design, let us just know it's a kind of an introduction. Right? So in this introduction components of a PEB building, see this. So roofing system we have here, and then this is called a ridge, and this is called a roof purlin, and this point is called a U. It's called U. So purlin which is provided here is called a U purlin. And the height from this ground level to this U is called a U height. See, there are different types of the terminologies there in this steel structure, unlike RCC. So here this is a wall system, and then wall gut. Wall gut also is called side gut. This is called a side gut. Most of the occasions in the case of the PEBs, side gut or wall gut element and this purlin element usually would be the same profile, jet sections and then jet sections, right? And then we know it's a rod bracing. See, how do I come to know when do I have to provide a rod bracing? How do I come to know how much space I need to keep for minimum distances and the maximum distances in the case of a purlins and then columns? So how can I come to know it? So each and every parameter which is there in the steel structure will be definitely a bit challenging thing for sure, because this RCC structures and concepts of the knowledge subconsciously we will be gathering it when we are going through the structures, because we are living in RCC structures. We are studying in RCC colleges. Colleges are made up with RCC buildings. We are living in RCC structures. So most of the occasions we are very close to the RCC, or we are very close to this conventional kind of the materials which are being used popularly. Like we know painting, brickwork, slab, beam. Everything is known to us. Even though people who are not having this civil engineering background, they have enough knowledge on the RCC structures. It's unfortunate to say. It is unfortunate to say that civil engineers are not all civil engineers, but some people who are not having though we are living in this very close environment for the RCC structures, some people may not be having enough knowledge on this, right? So when you come to this when you come to this PEB structures or steel structures, see, here we have a different terms. PU purlin, rigid frame, continuous frame, and this is called a gable end frame, and this is called a end post. This is called a gable wall, and this is called a side wall, and this is called a base facing. See how many words we have in this PEB. So this is a base facing. How much space I have to consider? Who is this guiding it? Where is this information available? How can I fix up this member size? How can I fix up this spacing between these purlins? Is this mentioned anywhere? Right? So these are all, every question or everything that is there in the PEB would be challenging. Right? Now I believe that you are now comfortable. Now you are okay with the components that are given here. So my consideration, or from this picture you just can notice, like this frame is called a rigid frame. You can see it is a rigid frame, and these are called the purlins. These are called side girds, and this is called cross bracing. Here we have a cross bracing, right? So these elements are enough. This information is enough, right? And this portal frame or this frame is called main frame or main structural component. Remaining elements like purlins and the side girds would be usually called as secondary members. Of course, sometimes this bracing system also. Sometimes the bracing system also is called a secondary system or secondary elements in the steel structures, right? Now let's go to this. This is the cross section of this one, PEB, and here you can see. So what is this? So here I have a column, rafter, the same components that we are now noticing or observing in the case of a cross section. See, in the case of a cross section, this is called ridge line, and you can see this. This is called U strut, and this is U height, and this is the space 1100 mm. This is called a floor finish level, and this is called a side sheeting, and this is the U strut. Right here I have a joint, like it is a It is an individual segment. It is an individual segment. Here I have one segment, and here I have one more segment, right? Because now we are making, or we are designing this structural component very effectively, so that we don't need to maintain uniform depth with these elements, or these elements are tapered elements, because we wanted to economize it. When you are economizing it, obviously we need to keep the sectional property wherever it is required to satisfy this bending moments and the shear forces, right? That is what economizing it. So that's why we have a different segments, or this frame is divided with the different segments. And if you can just see this column, bottommost we have a very thin cross section, and topmost we have a thick cross section. Our depth is higher. I can show you in the this picture. See here. So here at the base, or bottommost of the column, we have a less depth. Here we have a maximum depth. How and then why? Why it is so? Because it is how can I recognize now what kind of a structure, what kind of a support is this? I can say it is a pinned support. When I can say it is a pinned support, obviously our pinned support will have a less bending moment, at not even less, it's a zero bending moment. It's a zero bending moment at the base of the column. Very technically speaking, or theoretically speaking, you don't require any kind of a cross section to be provided at the base of the column, since the bending moment is completely zero when we are considering pinned supports. But why we are still using it? Because obviously we require a minimum depth of the member to accommodate bolting, to connect with the base plate, and base plate again will be connected with the bolting system, and the bolting system again will be connected with the pedestals. So obviously you require to maintain at least 250 to 300 mm depth of the column, even though we are using a pinned support. When do I need to use pinned support? That we will see in the next slides. Right. So now let me say, if I'm given with this kind of a plan, how can I design it? How can I study it? See, now I'm sorry to say, here the dimensions are not pretty clear. Here the dimensions are not really pretty clear. Anyways, now I'm going to say the structure length here, the structure length from here to here is 117 meters. 117 meters. Just imagine, it's 117 meters. 100 or 117 meters length. And what is this width of the structure? Width of the structure here, it is a 45 meters, of course, which is invisible here. I'm once again sorry for it. Right here, the width of this building is 45 meters. Here I have a length of the building 117, and of course for this 45 meters we have some central columns here. We have a kind of a central support. So here this span is again divided into two. One is 22.5 and then second one is 22.5 meters, right? Okay, now I'm given with 117 by 45 meters. Now how can I just fix up the columns location? And this is the side elevation, this is the side elevation, this is the side elevation, right? Let's go to this cross section. So this is a cross section. Here we have a cross section like this, right? How can I maintain this slope? And what are this? This is a floor level. FFL nothing but floor finish floor finish level. And here we have a roof extractor. Means it acts like a exhaust fan. It acts like a exhaust fans, right? This acts like a exhaust fans, right? Which will be just sucking this kind of a I can say carbon dioxide, whatever it is. Such kind of the things can be exhausted, extracted from this one, right? So what is this thickness? It is a 0.6 mm thickness, pre-coated corrugated steel sheet. Just see, imagine it's only 0.6 mm, not even 1 mm. It's not even 1 mm, right? So how can I remember the material thicknesses, material properties, and the size of those elements, or the size of those components when I am going to get into this structural designing, when I'm going to get a job in steel structural design? So are we really studying each and everything, or are we really remembering the things that we are getting from this academics, or what we are earning from this academic would be sufficient to try to get into this job? That's where usually one will face a difficulty, and one has to go through a kind of a hardcore process, right? That will be very heated kind of a process. So you need to struggle with this, and you need to be ready to face such kind of this challenges if the interest is stages when you are acting like a structural engineer, right? So this is the plan dimension 117 and then 45. See, it is now given to us to design it. What do I do? Now I understand the size of this building is 117 and the width is 45 meters. That's it. Architect or the person who is preparing this plan would not be giving us the structural details. Now we are the structural consultants. Yes, I go to this. I understand it is a 45 meters. I personally can say more than 30 meters. Try not to Try not to increase the space or span more than 30 meters to make the structure more economical. So here in this case, I have a 45 meters. Can I proceed with the 45 meters span? No, because 45 meters sometimes will give us uneconomical results. So how can I decide it? Because that can be decided by just making one simple frame, run the analysis and find out the bending moments. There will be understanding that having designed for 45 meters span would be just giving us the uneconomical results. Then you can keep one more central column, so that the design would be more economical. Just keep one vertical columns by introducing a kind of a tube. That's it. 45 meters span now has been divided into two. One is 22.5 and the second one is 22.5. That is the first logic. And the second logic. Now, if I have a 117 meters length, or if I have a so-and-so length of the structure, usually frame to frame distance would not be provided more than 6 meters. Usually, frame to frame spacing would not be provided more than 6 meters. If you want to just note this down, you can please note it. Usually, frame to frame spacing would not be provided more than 6 meters. Can you please open your calculators or mobile phones to fix up the span length? So now I have a 117 divided by 6 meters. So how many bays I'm getting? 19.5 bays. Obviously, I don't keep 19.5 bays, so I keep 20 bays. 117 divided by 20. What is the value that I'm getting? What is the value that we are getting? It's 5.85 meters. Yes, which is anyway less than 6 meters. Right? So 5.85 is the span, or I can say it is a bay to base spacing. It's a bay to base spacing. And in width direction, out of 45 meters, we are introducing one central column and dividing this to 22.5 and then 22.5 meters. Right? Now the basic picture is very clear to us. Now let's get into this. Now the basic picture is clear. 117 is the length, which is divided with the 20 bays. Each base spacing is 5.85 meters. If you want to note down, you can just note this down. And we have a 45 meters span. 45 meters span has been divided into 22.5 and then 22.5. Done. Now I'm okay with it. Now I'm ready with this modeling. And next thing is, now I need to know what kind of the code books that I need to refer for defining this structure. Right? So these are the list of the code books for loading. IS 875 part 1 for dead loads, and then part 2, R3, dead loads, live loads, wind loads. And then for the earthquake load, IS 1883. 2002 is previous code, 2016 is recent code. 2002 was previous code, and then 2016 is a new code, right? And the code books for design. So the first code books are dealing with this loading conditions. Second type is dealing with this design criteria for steel structures. And then Perlin and Runner, we have to refer the different code book, which is IS 801 1975 code book, which will be giving you the details of tubular sections and then jet sections, right? And then for deflection criteria, and of course, which is anyway dealing with the design criteria, so IS 800 2007. So we must be ready now with this code books. Now I'm just arranging whatever is required. Now I have an architectural drawing and I have studied the dimensions and I have divided it. I just have divided with a basic concept, like length is divided with the 20 base, and each base is to 5.85 meters, and width is divided to 22.5 and then 22.5. And then now I'm going through this code books. In the sense, I need code books for designing it, right? So modeling is now done, and then I need to go to this. These are the code books, and now we have to find out the primary members and the secondary members. So usually for the primary members, anyway, we have to use higher grade of steel to resist such kind of huge loads or to resist such kind of a huge spans, right? So usually for these primary members, like a frame in the sense columns and the rafters. This is the code book that needs to be verified. IS 2062 has to be verified. Grade of steel here is 350, and then ultimate strength is 490. So this is usually recommended when we have a larger spans or for PEB structures. And the secondary members, like basing and secondary members, it's a common grade of steel which we know it, that is 250 grade, whose ultimate strength is 410, right? And then bolts, splice bolts, and then class 8.8, and then purlin and side gird connections with 4.6 grade of bolts, and then anchor bolts can be verified or can be just extracted from 2062 code book. And these are the design assumptions, like main rafter columns are rigidly connected. So column base is pinned. We have to pin the column base when we have a clear height of the structure like 10 to 12 meters. If you have more than that, then it is recommended to go ahead with the fixed support. because you cannot just even that will be failed in the case of the erection criteria. And the lateral stability of the structure, how are we going to ensure it? Lateral stability of the structure is provided by the action of this portal action frame, because those are portal action. That is not a kind of a truss. We are not using truss. It's a portal frame. So lateral stability is resisted by this portal frame. And the longitudinal stability can be controlled by providing a cross bracing. Longitudinal kind of stability can be controlled by the cross bracing. And roof purlins are continuous supports on rafters. We know the roof purlins. Which are continuous here. We are saying it is a continuous like this. It is a continuous. Like sometimes what happens is we know the distance between these two base is 5.85 or 6 meters. Usually this rafter, this roof purlin would be cut 6 or 6.2 meters length, and that will be provided for the bay to bay. So when you are adjusting this purlin on bay to bay, then that will be acting like a simply supported member. But when you can take more than 12 meters, this one purlin, so you are just considering this as a continuous purlin. So that is what the assumption here. That is what the assumptions we have here. And then side runners are continuous supports on these columns also. So roof purlins and the country side runners both are having the same, based on the same assumption. Right now it is clear. It is now clear to us. The fundamental information like this. Length of the structure is 120 nearly, and width is 45, clear height is 10.5, and rafter spacing is 6 meters approximately, column spacing is 6 meters approximately, which is in fact 5.85 only, and then purlin spacing is 1.5. Purlin spacing usually would not be more than 1.5 because which is depending on the roof sheeting. So roof sheeting having only 0.6 mm thickness would not be able to resist the deflections due to its self-weight when I have a spacing more than 1.5 meters. So that's why it is recommended to keep 1.5 meters as the spacing between these purlins, right? The same thing with this girt also. Girt nothing but side rafter. I can show you once again here in this picture. See, this is girt and this is purlin. This is girt and this is purlin. For those cases, spacing is not more than 1.5 meters, right? Now let's go to this. Yeah. Roof slope is 1 in 10. Usually roof slope will be maintained 1 in 10, right? It would be around 1 in 6 to 1 in 10, but best roof slope is 1 in 10. And these are the loads that we need to consider, like dead loads and then collateral loads. Dead loads like self-weight and then roof sheet and then purlin weight. Some occasions roof sheet and then including fixtures, of course, including purlins, we can consider 25. Some structural engineers or some people would consider 5 kg per square meter extra load, right? And then collateral loads, nothing but hang loads. Hang loads, nothing but, for example, if I need to hang anything to this frame, vertical frame, if I need to hang any kind of a fire system, firefighting systems, then you have to add extra load. That load is called hung loads or hanging loads, also called as collateral loads, right? So these are the collateral loads. And then live loads, we know the live load is 75 kg per square meters for the roof, right? And this is as per IS 875, table number 2. And the next thing, dead loads are now done, live loads also now done. Next we have to go to this wind loads. So estimation of wind loads is easy in the case of a RCC structure, but when it comes to this steel structures, that is slightly tough because it is again depending on the type of the steel structure. So the steel structure might be a cladded structure or uncladded structure. Cladded structures nothing but closed structures like warehouses. Warehouses are closed or cladded with the sheeting, right? We can also find the structures which are uncladded or open structures. What are the